been doing so far. So,
All right, I have one question.
what's that?
It says state the alpha level. What's that?
Well, I guess this is where this week is when we figure out what we do with the data, what nation we want to make.
All right.
Alexis, did you mute yourself?
Yeah, it was echoing. I was just going to see if that would help.
Oh. All right. Makes it problematic. All right, Mom, you want to run through the quiz?
Yeah, we can.
All right. All right. All right, I've got everything up whenever you guys are ready.
I'm ready.
All right. Alexis, you got yours up? Okay, the true linear regression equation is y equals beta 0 plus beta 1x, where beta unknown. What are the null and alternative hypotheses for beta 1? So null is equal to, and alternative is not equal to.
Yeah.
The third one. Okay, a residual is I'm gonna have to look at this again because I don't 100% remember.
I think it is the difference between the observed value y and the value predicted for the regression.
Yep. I agree. There you go with that, Alexis. Oh, we lost Alexis. Just kidding. I'm sure she'll be back.
We'll just keep going.
Yep. Plotter residuals supports using linear regression when the residuals look normally distributed. Normally distributed, because that's when we use the QQ plot on the residuals to make sure they're normally distributed.
Yeah.
All right. Next 8 problems, we're using math, that one there. Okay. Let me pull that.
Compute residual from the data using software statement.
Hey, sorry guys.
Oh, it's all good. We just got up to question number 6.
Okay, cool. Let me just look at them real quick.
Worries.
I need to get a new computer. It freezes all the time. Okay. So question 3 is the last one, right? Not equal, then equal to.
Question. Well, I got the third one. It's equal to and then not equal to, isn't it? Our null is going to be equal to.
Okay.
And then our alternative will be not equal to.
Oh, that's right. Okay.
No worries. And then residual. We got a difference between the observed value y and the value predicted by the regression line.
Okay. And then the next one is what did you put for 5?
Residuals look normally distributed.
Okay.
That's when we take the residuals and put it in the QQ plot. All that good stuff. That's where we don't want like the megaphone or like a curved pattern or something like that.
Okay, cool.
And then nothing, the positive doesn't matter as far as the residuals. All right, so number 6. Use the confidence variable as the explanatory variable. Okay. Confidence interval as.
What number are we on?
Number 6?
Yeah.
All right, so I think we want to make sure we have the data in the right order on this one. Because they want us to use the confidence variable as the explanatory and the score variable as the response. So that's opposite of the way it shows up in the Excel doc. All right, so compute the residuals for the data using software. What statement best describes the residuals? Well, the residuals are not all negative. The variance of them.
It's not a linear pattern, is it?
Yeah, I'm sure that's what it is without putting it all into a QQ plot yet. Huh? What? I don't know. Let me pull it. I'm just gonna do a QQ plot real fast. Yeah, they're linear.
What the next one is based on the QQ plot. What can you say about these residuals? Are they clearly not normal? Are they fairly normal? Or should we be right?
They're fairly normal. Here, I'll show you the QQ plot. Here is my screen. All right, there. You see it?
Yes.
Looks fairly normal to me.
Yeah.
It's all pretty much in a straight line. So
Alright.
you know what's kind of annoying though about that previous question is that the residuals are between -40 and 25.
I know.
It doesn't say anything about a QQ plot though. So I'm almost inclined to change that to between the residuals are between -40 and 25.
Yeah, it's like it has which answer is more correct here.
Yeah, because I mean they are. I mean they're all between -40 and 25. So
Should we
and
try?
we don't know pattern linear pattern until we look at QQ plot. And we don't look at QQ plot until the next question. So
Yeah, and if we get it wrong, we know the other one.
yeah, I think I'm just gonna go to -40 and 25. If we get that wrong, then it's the second one for sure. All right. So use software to create a scatter plot of the data. Given the scatter plot, residuals plot, and the QQ plot, which of the 5 assumptions about linear regression are satisfied by this data? Check all that apply. All right. That's right, the residual plot. Forgot about the residual plot. That's the one that'll show us a pattern. Okay. All right. So the residual plot does not reflect the linear pattern at all. It's scattered.
So
All right. So there is a linear relationship between X and Y. That one.
the residuals are normally distributed, right?
Yeah. The X values are measured without error, and the observations are independent. I have to look at these requirements again.
The requirement for the last one is knowing the value of the y to tell you nothing about any other point.
Say that again.
So the last one it says knowing the value of y's tells you nothing about any other points.
All right. All right. So requirement observations are independent. So what we hope to see, knowing the value of one of the y's tells you nothing about any other points. Okay. And I think that's the case because there's no linear pattern in this.
Yeah.
So observations are independent. All right, so normal, well, let's look at normal error. So normal error, how to check QQ plot residuals. Points in the QQ plot are close to the line, which they are. So the variance of the error term is constant for all values of x. That is referenced by the QQ plot. As far as the first one, the linear relationship, that's where we're looking for the scatter plot being a hot dog shape and the residual plot being no pattern.
Yeah.
Which, looking at this, the residual plot is a scatter, and it is hot dog shaped for the other one. So that one's checked. And so we're looking at the fourth one now. X's are known constants. So we're looking at X's should be measured accurately and precisely. Okay. How are we checking this one? All right.
How do we know if it's measured accurately and precisely?
Well, in other words, the X's can be considered as known constants. All right. Right. X's known constants. Well, what are our X's? Our X's are the confidence scores. And those were obtained individually. An average of the individual scores. So the requirement is X's are fixed and measured without error. In other words, X's can be considered as known constants. Well, I mean, they would be because the X's are the means of the individual confidence intervals for each person on each question. So I don't know how it would be imprecise.
Yeah.
It seems pretty precise if they're taking the numbers and averaged them properly.
Yeah.
Which we're not told that it wasn't.
What is the residuals plot? I didn't really get a whole lot of time to study this before.
The residuals plot is here. Let me show you this one. Where's my thing? All right. Let's see. This is the residual plot right here.
All right. Then what's the other one?
The scatter plot.
Yeah. Where'd you get
this one right here?
All right. I see the scatter plot, but where'd you get the residual plot from?
The residual plot you complete by here. I'll show you how to do it. So what you do is you take these two columns, explanatory and residuals,
And graph them.
Yeah, then highlight, and you're going to use insert scatter. And then this first one right here, scatter with only markers.
Okay.
And that gives you your residual plot.
All right, that makes sense.
And basically what we're looking for on this one is that there's no pattern for this, that it's random like this.
Yeah, I got that part. I just didn't know where it came from.
Oh, got it.
All right. Thanks.
No worries. All right. All right, so I mean, it meets all 5 requirements, I think.
I do too.
Okay. What is B1, the estimate for the slope? I've got 12.695.
Yep.
Now construct a 95% confidence interval for B1. Input your answers for lower and upper. All right. So I've got lower at 10.674
Yep.
and then upper at 14.715.
14.715.
Yeah.
All right.
Is that what you got also?
Yeah.
Okay. All right. Question 12. Based on the evidence and using the level of significance, what decision would you make regarding hypothesis test for B1? All right. P-value is very small. So we're going to reject the null.
Yeah.
Not going to be because the p-value is less than the level of significance. Right, by that would be slope. If you reject the null hypothesis, what does it mean? Okay. There is sufficient evidence to conclude that the slope of the regression line is not 0. All right, so we're switching now to crocodile data.
Now, which one goes first? Request. Head length was first.
Yeah, head length to predict body length. Yeah, body length is going to respond to the head length. All right, so for this data, which variable is the dependent variable? Head length. Right, we're agreeing head length, right?
Yep.
Okay. All right. Now construct the 95% confidence interval. Determine margin of error. Okay. Well, let's do lower bound first, because then we can just subtract and divide by 2. So I've got the lower bound at 7.218
Yep.
and upper bound at 8.103.
Yep.
And then subtract those 2 and divide by 2. 0.443.
For 1 second. .442. Is that what?
I got 0.4425.
.4424 is what I got. But I used the full numbers. I didn't use the random numbers.
Oh, okay.
So
Well, so you just copied the cell, the 2 cells, and subtracted them divided by 2?
yeah, I didn't use the random numbers. I used the full number in the cell.
Yeah.
So
That. Yeah, 0.442435.
yeah, that's what I did.
Well, it's either going to be 0.442 or 0.443, depending on how they did this. Well, I'll go 0.442 and see what happens. All right, so based on your lower bound and upper bound for the last two problems, what can you say about it? 95% confidence interval contain the true value of V1. There's a 95% chance confidence will contain V1. There's insufficient evidence to reject the null hypothesis.
It's the top one.
Yeah, it's got to be. All right. Well,
Oh, dude. In this question,
which one?
8, the one that had select all the ones.
Oh, okay.
And 14.
14. The dependent. Oh, yeah, that's right. Because the dependent variable, it's a response variable, which is dependent upon the main variable. That's right. It's dependent upon the explanatory variable, which makes it a response variable. All right. I'll retake this real fast here.
Yeah, I'm going. My goodness.
We'll have to look at the requirements again, though. I'm going to come back to 8 so we can look at 8 again.
All right, that's what I was. there's a linear relationship. We know that.
We know, yeah, it's for sure that one.
It's for sure the third one.
Yeah, it's for sure the third one also. Observations are independent.
Yeah.
I think we established that one also. Because knowing the value of one y does not necessarily tell us anything about anything else.
Mm-hmm.
The question is about 2 and 4. The points in the QQ plot are close to the line, which they are. QQ plot are the residuals.
So maybe it's just not the X value one.
So the variance of the error term is constant for all values of x, which it is. The pattern residuals, yes. No megaphone shape, which doesn't have. Knowing the value of one of the y's tells you nothing about the other points. Which, yeah, that's the case. So I guess it's not the fourth one?
That's what I would think.
But I don't know why, other than,
It doesn't state that they were measured accurately.
yeah.
I'll do that and submit it and see what I get. Still missed it.
Still missed it?
Yeah, I did. I just didn't put the fourth one.
What the heck? I need to measure with that error. Okay. There's a linear relationship between x and y. Which there is. The scatter plot has a hot dog shape. The residual plot has no residuals. So it's got to be the first one. The points in the QQ plot are close to the line, which they are. Maybe we do know knowing the value of one of the y's tells you nothing about the other points. I guess maybe we don't know that, or maybe we do know that.
I don't know.
Which of the following 500 are satisfied by this data? Oh, maybe it is only the top 3, and that's because based on the data, the scatter plot, the residual plot, and the QQ plot, we don't determine the bottom 2 from the scatter plot, the residual plot, and the QQ plot.
Oh, that makes sense.
That's lame.
It's like a trick question.
Yeah, that's what it is. That's lame.
Did you get 100%?
Yeah. I should have submitted mine first.
No, you're fine. 1 point don't matter.
All right. Well, I guess Alexis isn't coming back. He must have had computer issues. So I guess your part, I suppose, if you want to take a look at it, if you have any questions, we can just email each other.
Alright.
But yeah, I think probably just eyeball maybe some of the models we have in the reading and just kind of base it off of that.
Alright, just kind of follow.
Yeah, and then we can all just kind of put our input in as you get stuff done with it, or if we see anything, we can just send over to.
Alright.
I think our inference is pretty much clear that it's cheaper to fly on July 1st than it is on April 1st.
Yeah.
I think we've kind of determined that through our data.
I'll work on this and do as much as I can and do it the best I can. And just Wednesday, we'll take a minute and look through it and change stuff. I'll submit it after that.
Okay, that sounds good.
All right.
All right, man. Well, then I'll see you on Wednesday.
All right. See you, man.
All right, man. Take it easy.
Bye.